DC Motors by Colin Hines, Colin Pausch, Tyler Berg, and Aaron Berge. Principles of operation. A DC motor is an electrical motor that converts electrical energy into a mechanical energy output. The basic working principle is that whenever a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. The direction of the force can be determined by using Fleming's right-hand rule. Fleming's right-hand rule states that when the current carrying conductor is within a magnetic field, the force that acts on the conductor is in the direction perpendicular to both the magnetic field and the current. The magnitude of the corresponding force can be found using the equation force equals magnetic flux times current times length of the conductor within the magnetic field. Principles of operations continued. The magnetic field within the DC motor is provided by field windings or by using magnets that are permanently mounted within the motor. Field windings are the insulated current carrying coils on a magnetic field that can produce a magnetic field that is used to excite a motor. Within DC motors, there is back EMF present. The back EMF is caused by magnetic drag that opposes the conservation of energy. The speed of the motor is directly proportional to the amount of back EMF present within the motor. If a load is placed onto the motor, the speed of the motor and back EMF will decrease. The back EMF will make the DC motor a self-regulating device. Types of DC motors. There are four main types. The first one is the permanent magnet, series, shunt, and compound. Permanent magnet DC motor. It is a type of DC motor that uses a permanent magnet to create the magnetic field used to operate the motor. This type of DC motor is very simple in construction, since the magnetic field is fixed and the motor cannot be controlled externally and are used when there is no need to control the speed of the motor. These types of motors are found in many types of toys and are the dominant motor type in automobile power accessories like windshield wipers, washers, and blowers for the air conditioning. Series DC motor. This type of motor is a self-excited motor. The field windings of this motor are connected internally in series to the armature winding. The field windings are exposed to the entire armature current, unlike a shunt motor that will be talked about on the next slide. These motors should never be started without some mechanical load. Shunt DC motor. This is also a type of self-excited motor. In this motor, the field windings are shunted to, or they are connected in parallel to the armature windings of the motor. Since they are connected in parallel to the armature and the field windings experience the same supply of voltage. This motor is interesting because when the motor's running condition changes from load to no load, there is little change in the speed that is running. But when this type of motor is started, it should never be started under a heavy load. Compound DC motor. This is also a type of self-excited motor like the series or shunt motor. This motor is made up of both series field coils and shunt field coils. Both of these field coils provide for the required amount of magnetic flux used for desired speed. This motor takes the better properties of the series and shunt motor and brings them together.
Characteristics of DC motors. DC motors run on either DC power or AC line voltage with a rectifier. They have operating speeds of 1,000 to 5,000 rotations per minute, an efficiency rate of 60 to 75%, high starting torque, low no-load speeds. Three characteristic curves are considered important for DC motors. These three characteristic curves are torque versus armature current, speed versus armature current, and speed versus torque. Characteristics of DC series motors. It can be seen from the figure. For a series motor, torque increases with current, speed decreases with an increase in current, and in order for torque to increase, there must be a decrease in speed. Characteristics of DC shunt motors. For a shunt motor, torque increases with an increase in current, speed remains constant with a change in current, and there's a slight decrease in speed as torque increases. Characteristics of DC compound motors. When it comes to compound motors, Torque increases with current for both types of compound motors, and speed slightly decreases with current for the cumulative compound motor and generally has a slight increase for the differential compound motor. Advantages of DC motors. They operate on DC power supply without a control. They're inexpensive controls for speed regulations, generally a low-cost motor option, and easily pair with gear reductions. Disadvantages of DC motors. They have high maintenance due to low brush life. Basically, they have a 2,000 hour maximum in continuous duty applications. There can be a cogging at speeds of less than 300 rotations per minute. There is significant power loss on full wave rectified voltage, and they have high starting torque, can damage reducers.
Principles of speed control. When looking at speed control, there are some proportions that can be noted. Speed of the motor is directly proportional to the supply voltage. The speed of the motor is inversely proportional to armature voltage drop. Speed of the motor is inversely proportional to the flux due to field windings. So how are DC motors actually controlled? They're controlled by varying the supply voltage to the motor, varying the flux and the current through the field windings, and varying the armature voltage and resistance. The first method is a flux control method. For this method, a magnetic flux due to field windings is varied to control motor speed. Magnetic flux is controlled by current through field windings. And this is achieved by using a variable resistor in series with the field winding resistor to control the current. For the voltage control method, this is simple and just controls the supply voltage to the motor. One method used is the Ward-Leonard system. The Ward-Leonard system uses an AC motor-driven generator to provide a variable voltage to the armature. The other most popular method is PWM, pulse width modulation. To achieve the speed control of a DC motor, PWM involves the application of varying width pulses to the motor driver, which controls the voltage applied to the motor. This method is often proven to be very efficient as power loss is kept at a minimum and doesn't involve any use of complex equipment. Overall, voltage control method is often desired for speed control as it's the most efficient method. The two methods mentioned before, flux and armature control, have some drawbacks. The flux control method can affect commutation, and the armature control method involves a large power loss due to its usage of a resistor in series with the armature, which is why the supply voltage is the desired method.
Typical applications. DC motors are commonly used for driving constant torque loads. Examples are a ski lift, which is shown to the right, conveyor belts, and elevators. All of them require the constant speed and torque characteristics that you get from a DC shunt motor. Also commonly used in fractional horsepower applications, such as windshield wipers, pumps, and washing machines. They are used in fractional horsepower applications because they're very low in cost, they have versatile sizes, and they can run reversible processes. Servo motors. A majority of servo motors use a DC motor. Large industrial servo motors are about the only kinds that typically don't use a DC motor. Smaller applications that do use a DC motor include a radio-controlled airplane, which is shown to the right, metal cutting machines like a lathe shown below, camera autofocus, which adjusts the lens in and out to get the right focus for a camera, and textiles. Robotics. Robotics commonly use fractional horsepower DC motors. They are typically placed at every joint of a robot. Like the top picture shows a DC motor at the base, at the shoulder, the elbow, the wrist, and the gripper. Reasons a DC motor is used in robotics is because they have high efficiency, they are very cost effective, They have variable sizes and they have very high precision in their movements. And this is our references, and that's a wrap.